Human mind is a magnificent organ. It's allowed us to walk on the moon, to discover the secrets of life and the physical universe, and to play chess almost as well as a computer. But the mind throws up a major paradox. On the one hand, the human mind is an engineering masterpiece. No robot can see, move, speak and understand, or use common sense nearly as well as a human being. You can't go to an appliance store today and buy a robot that will put away the dishes or run simple errands. And the reason is that the mundane mental activity that we take for granted, such as picking up a plate or understanding simple instructions, turn out to be formidable engineering feats that no human engineer has been able to duplicate in silicon. On the other hand, for all its engineering excellence, the mind has many apparent quirks. For example, why is the thought of eating worms disgusting? They're a perfectly nutritious source of animal protein. Why does the male of our species do insane deeds, such as challenge each other to duels or to murder their ex-wives? Why do people in all cultures believe in ghosts and spirits? Why do fools fall in love? Well, I propose to answer both of these questions, what accounts for the engineering excellence of the mind and what accounts for its quirks, using three key ideas. The first idea is computation. In particular, that the function of the brain is information processing or computation. I think this is a profound idea for a number of reasons. One of them is that it offers a solution to the ancient mind-body problem. Namely, how does something as ethereal as a thought or a belief or a desire cause something physical like behavior? In particular, let's say you wanted to explain why Bill just got on the bus. To answer that question, you wouldn't have to put his head in a brain scanner. You wouldn't have to run a computer simulation of a neural network. The best way to get an answer would be to ask him, and he'd be likely to say something like, well, I want to visit my grandmother, and I know the bus will take me there. Now, no other theory will have as much predictive power as that common sense one. If Bill hated the sight of his grandmother, or if he knew that the route of the bus had changed, his body would not be on that bus. And that raises the puzzle. The beliefs and desires that explain and predict those behavior are colorless, odorless, tasteless little nothings, but nonetheless they're as potent a cause of physical events as one billiard ball clacking into another. Well, I think the computational theory of mind resolves that paradox by explaining beliefs as a kind of information encoded in patterns of neural activity in the brain, explains desires as goal states, such as those that organize artificial intelligence programs, and explains intelligence in terms of computation, computation being what happens when one pattern of information causes another, and the relation between the first and the second mirrors some law of logic, statistics, or cause and effect in the world. Another reason that the computational theory of mind is so powerful is that it sets an agenda for the science of mind, psychology, and the science of brain, neuroscience. For example, in studying how people think, a central question in cognitive psychology has been, what is the form of the data structures that represent information in the brain? For example, if I were to ask you a question like, what shape are a Cocker Spaniel's ears? Or if the capital letter N was rotated on its side, would it form some other letter of the alphabet? Most people report an experience that's like seeing these patterns in the mind's eye, and which I think can profitably be modeled as a kind of graphic representation in the head, not unlike those used in computer graphic systems. Similarly, in the direct study of the functioning of brain tissue, the computational theory of mind has posed the questions that brain scientists want to answer. An example is the current hot topic in brain science, the search for the neural basis of learning and memory. Well, of the thousands of metabolic processes in the brain, how will we know when we found the seat of learning and memory? Well, it's when we find a process that satisfies the requirement of being able to store and retrieve information. The computational theory of mind should not be confused with the computer as a metaphor of the mind, because it's undeniable that the human brain and the digital computer that you buy in a store are very different in many ways. The computers are serial, doing one thing at a time. Brains are parallel, doing hundreds of thousands or millions of things at once. Computers are fast and reliable. Brains are slow and noisy. Computers display screensavers with flying toasters. Brains do not. But the point isn't that the digital computer is literally a metaphor for the brain, rather that the explanation for how the hunk of matter that we call a computer and how the hunk of matter that we call the brain can accomplish intelligence have a fundamental principle in common, namely information processing. An analogy would be that we invoke the same laws of aerodynamics to explain what keeps airplanes in the air and what keeps birds in the air, but that doesn't commit us to an airplane metaphor for the bird and cause us to look to see whether birds have jet engines and complimentary beverage service and headphone jacks and so on. A final comment on the computational theory of mind is that it's by no means an obvious or banal observation. In fact, I think it runs counter to the dominant way of thinking about the human mind in our culture and in everyday speech. You're apt to hear the following kind of explanation of behavior in ordinary conversation. If only Fred had an outlet so he could let off steam, vent his hostility, and channel his rage rather than bottling it up, he wouldn't have exploded last Tuesday and shot up the post office. Now, this is an example of the hydraulic model of the mind, the idea that thinking is powered by an overheated source of fluid or pressure that has to be properly diverted through channels or else it will leak out. We know that the brain doesn't literally work by the flow of energy or pressure, but rather by the flow of information. And that leads to an interesting scientific question. Since it's undeniable that people act as if they explode or they need to let off steam, but we know that the brain doesn't literally work that way, it forces us to ask the question, why is the brain going to so much trouble to simulate energy or pressure, given that it doesn't literally work that way? And that's a question that I'll return to at the end of the talk. The second idea after computation is evolution. All over the living world, we are impressed by signs of complex design in the living world. The organs of animals and the parts of plants have improbable organization that brings about some unusual outcome. For the classic example being the eye, which has a lens and retina and iris and many unusual kinds of tissue, all precisely arranged to form an image on the light-sensitive surface at the back. It's impossible to make sense of the eye, to come up with a coherent description of it without talking about it as a system that in some sense appears to be designed for clear image formation. This makes much of physiology and anatomy a kind of reverse engineering, where if forward engineering consists of coming up with a goal and building a machine that carries it out, reverse engineering consists of finding a complex object and trying to infer the goal that it was designed to carry out. Now, of course, unless you're a creationist, you don't literally believe that there was an intelligent engineer that designed the eye with some foresight or goal in mind, but instead you appeal to Darwin's theory of natural selection, which, as Richard Dawkins has eloquently explained in The Blind Watchmaker, is the only physical process that we know of that's capable of generating the appearance or signs of engineering in the natural world. Now, the human mind is a complex device showing signs of sophisticated engineering. A simple proof of that is the fact that despite decades of effort, human engineers have been unable to duplicate what the mind does in robots and computers, and that suggests that psychology ought to be a form of reverse engineering, of figuring out what purpose, in the special biological sense of purpose, the human brain evolved to fulfill. And since the kind of design that we see in the mind is not the work of an engineer with foresight, but rather a consequence of natural selection, it suggests that the ultimate answer to the question, what is the function of the mind, is survival and reproduction in the environment in which the mind evolved, and that would be the hunter-gatherer or foraging lifestyle in which we spent 99% of our evolutionary history until the very recent invention of agriculture in a small number of areas in the world just over 10,000 years ago. Now, the third idea, after computation and evolution, is specialization. I don't think there's ever going to be a theory of everything when it comes to human thought and feeling. I don't think the brain is made of some wonder tissue that can immediately explain everything that we think and feel. I don't think there'll be some magical set of equations or single computer model that will do it all. And that's because the mind solves many different kinds of problems. Seeing in 3 dimensions, moving arms and legs, understanding the physical world, finding and keeping mates, securing allies, and many others. These are different kinds of problems, and the tools for solving them are bound to be different. We know that specialization is ubiquitous in biology. The heart is different from the lungs because the heart is an organ for pumping blood and the lungs are a device for oxygenating blood, and an organ that is good at one is necessarily going to be bad at the other. And this specialization goes all the way down. Heart tissue is different from lung tissue. Heart cells are different from lung cells. Many of the molecules making up heart cells are different from those making up lung cells. And I suspect that the same is going to be true of the circuitry of the brain, that the brain is going to be organized into the mental equivalent of systems, organs, tissues, and so on. So putting these 3 ideas together, what I suggest is a fruitful way of understanding the mind is that the mind is a system of organs of computation that allowed our ancestors to understand and outsmart objects, animals, plants, and one another. And I'll illustrate this idea now by 2 concrete examples, one from how we perceive the world and the other from the world of emotions. Let me begin with the problem of perception, in particular the problem of vision. When you go to the movies and see a director's idea of a robot, the problem of vision is sometimes conveyed to the audience by showing the world from the robot's eye view using some kind of cinematic distortion. Perhaps, as in the Terminator, there'll be a wide-angle view with crosshairs and pull-down menus, or in 2001 there'll be a red tint and a fisheye view. But this is quite misleading because you have to ask who or what inside the robot is looking at that display, who's reading the menu or looking at the crosshairs. Obviously, there isn't a little man inside the robot narrating to the robot what it sees. A better way of thinking about the problem of vision is to imagine that the input to vision is a massive spreadsheet with 1 million numbers corresponding to the light brightnesses of each point in the visual field, the entire spreadsheet coming about as a result of a projection that's formed when light bounces off objects and is focused by the cornea and the lens of the eye onto the 2-dimensional retina, at which point the pattern of light is transduced into 1 million neural signals. The job of the rest of the brain is to crunch those numbers and to recover an understanding of the 3-dimensional structure of the world from the patterns that are implicit in those 1 million numbers. Now, the brain has evolved many tricks for recovering 3-dimensional shapes from the 2-dimensional retinal array. And I'll just talk about one of them called shape from shading. It relies on a basic principle of physics that the shallower the angle of a surface with respect to a light source, the less light it reflects back. And just to illustrate that, don't know if you can see this, but as I tilt the card with respect to the flashlight, the beam of light changes from a bright concentrated spot to a much more diffuse area that's smeared across the surface and which is therefore necessarily dimmer. Now that has nothing to do with the mind, that's just a law of physics, but the mind has evolved a trick that exploits that law of physics by basically running it backwards. The dimmer a patch on the retina, the shallower the angle of the surface, and with that trick the brain can reconstruct a three-dimensional surface from the thousands of facets whose surface angle is estimated from the brightness on the retina. That's what would allow us, for example, to tell the difference between a ping pong ball and a white poker chip from the subtle pattern of shading across the surface. However, in interpreting brightness as coming from differences in angle, this algorithm, the brain, makes an assumption about the world. Basically, that the world is like this, a homogeneous gray card, and that it predicts that if that assumption is violated, if we're in a world in which lightness is not uniformly or randomly distributed across a surface, our shape from shading module should be fooled into seeing shapes that aren't there. Now this isn't just a theoretical prediction, but it happens all the time. One example is television. If an alien scientist were to come to this planet, they would surely be astonished to discover that the typical member of our society spends 6 hours a day staring at a piece of glass in front of a box. Well, why do we do it? Well, it's because the box has been engineered to deliver a highly non-random pattern of shading across the surface of the glass, unlike the gray card, that the brain, assuming a constant lightness, interprets as having come from complicated three-dimensional structures. And for that reason, we hallucinate a 3D world behind the pane of glass. Another example is makeup. People who are skilled in applying makeup know that if you apply some blush to the sides of the nose, the eye of the beholder will interpret darker surface as steeper surface, and that will make the sides of the nose look more parallel, and the nose will look smaller. Conversely, if you put light powder on the upper lip, the eye of the beholder will interpret light surface as more perpendicular surface, and that gives rise to that full-lipped, pouty look that the models strive for. But I bring up these examples to make a more general point, which is that many of the illusions, fallacies, and maladaptive behaviors that we see in humans may not come from fundamental design flaws, but rather from a mismatch. A mismatch between assumptions about an ancestral world built into our mental faculties, such as that surfaces are uniformly or randomly colored, and the structure of the current world, such as television or makeup, which deliberately violates those assumptions. And I think this sheds light on what would otherwise be puzzles for biology, such as why people eat themselves into an early grave with too much junk food, use contraception, which when you think of it is a form of Darwinian suicide, you're taking active steps to prevent your genes from propagating, or gambling and buying lottery tickets, sometimes known as the stupidity tax. Well, I think the answer is that our mental faculties assume a world in which sweet foods are nutritious, which is true of the world that we evolved in which the only sweet foods were basically ripe fruit, until the invention of agriculture, which violated that assumption by churning out tons of sweet foods that were not nutritious. It assumes a world in which sex leads to babies, which again was true of the world we evolved in until the very recent invention of reliable contraception, and a world in which statistical patterns have underlying causes, again, which is true of the world almost by definition, with the exception of machines that are engineered precisely to display statistical patterns without any causes, namely gambling machines. Okay, let me turn now to an example of our emotional life, and I'll begin with a puzzle. Why are our emotions about other people often passionate and seemingly irrational? Examples would be pursuing vengeance until the day you die, far out of proportion to the initial injury, defending your honor with duels and other public displays, falling head over heels in love and offering to slay dragons and losing your appetite and so on. The traditional theory for human passion, it comes out of the Romantic movement 200 years ago. The Romantic theory is that all of us house a primal force, part of our legacy from nature, that's fundamentally irrational and maladaptive unless it's channeled into art and creativity. And again, that brings up the hydraulic metaphor that I mentioned at the beginning of the talk. Well, I'm going to present a very different theory that comes from a number of economists and game theorists that I'll call the strategic theory, coming out of the theory of paradoxical tactics, that a sacrifice of freedom and rationality can paradoxically give an agent an advantage in promises, threats, and bargains, cases in which two parties have both overlapping and distinct interests. And just to illustrate how unromantic this theory is, I'm going to use it to reverse engineer romantic love. Now, as it happens, romantic love has been studied for several decades by social psychologists and sociologists who have told us that there's actually a rational component to romantic attraction. Basically, smart shopping. As anyone who has recently been on the single scene will attest, love is a kind of marketplace where all of us at some point in our lives have been in search of the richest, best-looking, nicest, smartest person who will settle for us. However, your dreamboat is a needle in a haystack, and you might die single if you wait forever for him or her to show up. So all of us have to trade off value against time, and at some point, set up house with the best person we found so far. Now, this leads to a prediction which is abundantly fulfilled, and that is assortative mating by mate value. That if you look at any large sample of couples, you'll find that the husbands and wives, or the boyfriends and girlfriends, are closely matched in desirability to third parties. That is, the 10s marry the 10s, and the 9s marry the 9s, and the 8s marry the 8s, and so on. But I think we'll all agree that this conclusion, well established in social psychology, does leave something out of the whole process. And that is the irrational part of love, the involuntariness and the caprice. All of us know people, in fact I'm sure many of us are people, who can remember being fixed up with someone who would seem to be the perfect match. You can tick off all of their traits. They're nice, they're good looking, they're good sense of humor, and so on. But for whatever reason, you just don't click. Cupid didn't strike. The earth didn't move. Why would we as a species be built this way? Well, in fact, there are a number of economists who say this is exactly how you ought to build a species, because of an inherent problem for the perfectly rational strategy that I alluded to at the outset that they call the commitment problem. Romance is a kind of promise. You're promising to spend the rest of your life with someone, to bring up children together, to forego opportunities to be with someone else. And there's an inherent problem with any promise, which is that a hypothetical rational agent might find it in his interest to break the promise. And that the problem is, how do you guarantee that the promise is credible? In the case of romance, since you've had to set up house with the best person you found up to a given time, by the law of averages, someone better is bound to show up in the future. The only question is when. Perhaps Tom Cruise or Cindy Crawford will move into the apartment next door and be momentarily available. At that point, a perfectly rational agent would drop you like a hot potato. On the other hand, since you are also a rational agent in this hypothetical scenario, you could anticipate that, and you would never have made any kind of agreed to the promise to begin with, anticipating that it would be in the interest of the other party to break it sooner or later. Well, the solution is that if you don't decide to fall in love for rational reasons, perhaps you're less likely to decide to fall out of love for rational reasons, and that the very involuntariness of romantic love serves as an implicit guarantor of the promise. It's an example of one of many examples in which a lack of freedom or rationality is paradoxically an advantage in situations of negotiation between two intelligent parties. For example, the law that allows the bank to foreclose on your mortgage and repossess your house decreases your freedom to live in the house without paying back the bank. On the other hand, it's only that law that made it worth the bank's while to lend you the money to begin with. And so, paradoxically, that law works to the advantage of the borrower, not just the lender. Another example is the law that defines the rights of corporations. It says that corporations have the right to sue and the right to be sued. The right to be sued? What kind of right is that? Well, it's the right to be able to engage in a promise with some other party that has the potential to be harmed if you renege on the promise, and therefore it makes your promises more credible. Now, this is a clever idea. It comes from the economist Robert Frank and the theorist Thomas Schelling and others. But is there any independent evidence for it, aside from the fact that it seems to resolve this paradox? Well, I think there is. One of them is simply the fact that romantic love does appear to be a part of the biological repertoire of the human species. And this is a controversial claim. The consensus among many intellectuals is that romantic love is a recent invention of provincial troubadours or Hollywood scriptwriters or romance novelists. But in fact, a recent anthropological study by Yoni Harris has surveyed the world's cultures and finds that reports of an emotion that we would identify as romantic love can be found in all the world's cultures. Indeed, it raises the question of why it's such a common belief that there's no such thing as love. Well, I think the reason is that romantic love is a nuisance to parents who would just as soon barter or sell their children in arranged marriages and therefore have an incentive to spread the disinformation that romantic love doesn't exist. But apparently it does exist. Another is the psychology of courtship. If you were to whisper in your lover's ear, "You're the nicest, smartest, best-looking, richest person I've been able to find so far," it would probably kill the romantic mood. The way to a person's heart is to declare the exact opposite, to say that the emotion is elicited by the unique idiosyncratic properties of the individual, I can't help falling in love with you, and to emphasize how involuntary and irrational it is. I want you so bad, it's driving me mad, etc., etc. I also think that another puzzle that I think this theory resolves is why the emotions tie up the body as well as the brain. When we're in the throes of passion, romantic or otherwise, we show it. We blush, we blanch, we tremble, we sweat, our voice croaks, we get expressions on our face. And this has long been a puzzle in physiology. And I think one explanation is that we are giving a credible signal that our current course of action is not under the control of the voluntary circuits of the cerebral cortex, and therefore is a course of action that we have talked ourselves into and could talk ourselves out of, but rather that course of action is under the control of the limbic system circuits that control the physical plant of the body, and therefore is a course of action that we can't so easily talk ourselves out of. Now, if passionate love and loyalty are guarantors that our promises are not double-crosses, by symmetrical logic one could show that passionate vengeance or a thirst for revenge or desire to defend one's honor is a guarantor that our threats are not bluffs. There's a problem with issuing a threat, and that is that the target of the threat might force you to carry it out. And you could get hurt if you carry out a threat. Since the target of the threat can anticipate that, they can, in a sense, threaten you right back by refusing to comply, and therefore render the threat a meaningless bluff. Well, the way out of that problem is to be so constituted that it would be an intolerable insult not to let the insult go or the injury go unavenged, and to pursue revenge or defense of honor, even regardless of the costs that you incur. It's only that makes the threat credible to begin with. Well, let me conclude and acknowledge that to some people the kind of analysis that I've been presenting might be seen as a cynical view of human nature. And most people don't like to think of themselves as a system of computers designed by natural selection to promote survival and reproduction. On the other hand, I think that there are some facts that are simply undeniable to any scientifically literate person, namely that the mind is a product of the brain, that the brain is a product of evolution, and that evolution is not guaranteed to produce niceness. On the other hand, I don't think it's a cynical view, and in fact I think it offers, in a way, more room for optimism than some of the older views of thinking of the human condition. The idea that of the three ideas that I opened with, I think the idea of computation implies that the human mind is not just a bag of crude drives and reflexes, but is composed of intricate, ingenious, and powerful software. The idea of evolution suggests that our legacy from the natural world is not just greed, aggression, lust, a thirst for blood, a territorial imperative, and other nasty drives that have been mistakenly equated with Darwinism, but that by the same token, our capacity for love, friendship, and a sense of justice are also the legacies of biological evolution. Finally, the idea of specialization suggests that some parts of the mind, those with the longest view of the future, can devise ways of outsmarting the other parts of the mind. And with that, I'll conclude. Thank you very much.